Hey, welcome to part 2 of the linear and nonlinear relationships unit. We're back looking at straight lines, and after last week where we did a review of coordinate geometry, today we're going to be looking at parallel and perpendicular lines. Remember, parallel lines are lines that run in the same direction, they never meet, and so the symbol for parallel lines just looks like two vertical lines running side by side. Okay, so the symbol looks like this. Whereas perpendicular lines, they're lines that meet at right angles. Right, so like our walls meeting the floor. And that's what our symbol looks like. Here's our floor, here's our wall. Okay, meeting at right angles. Nice and easy. When we're talking about two lines, we refer to their gradient to know which slope they have. And if we've got two lines, we need to differentiate between the gradient of one line and the gradient of another. So if line 1 has a gradient m1, then we would say that line 2 has gradient m2. You guessed it. So if we've got two lines, they've got gradients m1 and m2, then we can look at if they're parallel or if they're perpendicular based on the following. So these two lines are going to be parallel if their gradients are equal. Right? So if m1 is equal to m2. However, the two lines will be perpendicular if something else happens, and we'll get to that in a sec. Okay. Let's draw some lines. So I'll put some grid paper on. Okay, let's start off real simple and draw a line that has a rise of 1 for every 2 that it goes across. So let's say it goes across 1 and up 2, across 1 and up 2. So that's a gradient of 1/2. So let's say this is line 1 and it has a gradient of 1/2. If we were to draw a line that is parallel to that first line, then it would be a line that also has a gradient of 1/2. So our second line has a gradient of 1/2 as well. So these two lines are parallel. They run in the same direction. We'll put parallel symbols on them. Okay, but let's look at perpendicular lines. So we'll draw another line like the first, or like either of them really, that has a gradient of 1/2. So for every 2 across, it goes up 1. If we were to draw a line that is perpendicular to this line, it would look something like this. Right, there's a line that cuts our original line at right angles. Now we know that our first line had a gradient of 1/2. But what does our second line have a gradient of? Well, if we choose some points on the line and form a little right angle triangle, we can see that this line is going down 2 and across 1. So it has a negative gradient because it's running downhill from left to right. The rise is 2 and the run is 1. So it's kind of flipped around from what we had with our first line. this gradient is negative 2 over 1, or just negative 2. And these are two lines that are at right angles. So let's go back to what we were writing over on the left. That two lines are parallel if the gradients are equal, but two lines are perpendicular if m1 multiplied by m2 gives us negative 1. See how 1/2 times negative 2 gives us negative 1? Alright, that's just one example. Any set of perpendicular lines, when we multiply the gradients, we'll get negative 1. Another way of looking at it is that if we know one gradient, well, the other gradient is going to be negative compared to the negative version of the first gradient, and it's also going to be the reciprocal. It's going to be flipped. Okay, so 1/2 and negative 2, one's positive and one's negative, and 1 over 2 is the flipped version of 2. So that's another way to look at perpendicular gradients. So what are some other examples? If I told you that one line had a gradient of negative 4, then the line perpendicular to it would have a gradient of 1 over 4, positive 1 over 4. Or if I told you a line had a gradient of 5/7, well, the line perpendicular to that would have a gradient of negative 7 over 5. Right, so just switch the sign and flip the fraction. And remember, if it's just a whole number, well, a whole number like negative 4, right, it's over 1. So if that helps you flip the fraction. Alrighty, let's do an example. In this example, we want to find the equation of a line. Now this line passes through the point 2, 4, and is perpendicular to this line. The line represented by y equals 3x minus 2. So, what is the equation? That's what we're trying to figure out. Well, first of all, it might help to know what is the gradient of this other line. This other line is in the form y equals mx plus b, where m is the gradient. So, just by comparing, we can see that m must be 3 in this other line. So if m is 3 in the other line, so the first line that we've been given, the gradient is 3, then our line, the second line that we're going to find the equation of, it must be minus 1 on 3. Right, because 3 times minus 1 on 3 is just negative 1. Right, that's sort of like our little proof for showing two gradients are perpendicular. So we now know the gradient of our line, and we know what point it goes through. So that means we can use y minus y1 equals m outside of x minus x1, the point gradient form. x1, y1 is 2 and 4, and m is minus a third. So let's sub everything in. Y minus 4 equals minus 1/3 times x minus 2. Now if we want to put this into general form, remember that we don't want any fractions, so we're going to multiply both sides by the denominator of our fraction, which is 3. On the left hand side we'll get 3y minus 12, and on the right hand side the 3's cancel out to leave us with minus 1 lot of x minus 2. Expanding those brackets out, that's minus x plus 2. Now general form, we want everything over on the left, so we're going to add x to both sides and take away 2 from both sides. And that leaves us with x plus 3y minus 14 equal to 0. Now if we did want to graph this, we might find it better to put our equation in y equals mx plus b form. Or let's just say you were asked to put it in y equals mx plus b form. Back at this step here, what we would do is, instead of getting rid of the fractions, y equals mx plus b form is where we want to have y on the left hand side. And it's already there, it's just got a minus 4 attached to it. So what we would do is expand out the brackets, minus 1/3 x, and then minus 1/3 times minus 2 gives us plus 2/3. And then we would just plus 4 to both sides. Plus 4, plus 4. So that we get y equals negative 1/3 x plus 4 2/3. So if we wanted our equation in y equals mx plus b form, that's what it would look like. Otherwise, it's x plus 3y minus 14 equals 0. Alrighty, that finishes off part 2. Thanks for watching.